Okay, here are some more antiderivative rules that you should just memorize. And some of these should be kind of obvious. For example, the antiderivative of e to the x dx is e to the x plus c, which we know because the derivative of e to the x is e to the x. Now, you always got to keep in mind when you're doing derivatives or antiderivatives, this x is just a dummy variable. This is true no matter what variable I had. The antiderivative of e to the u du would be e to the u plus c. Or the antiderivative of e to the t dt would be e to the t plus c. The antiderivative of cosine of x dx is sine of x plus c. So you got to keep in mind, let's write our derivatives over here. The derivative of sine is positive cosine. The derivative of cosine is negative sine. So we learned those rules months ago. Going backwards, it's really easy to get that negative mixed up. Derivative of sine is positive cosine, so antiderivative of cosine is positive sine. Antiderivative of sine dx is negative cosine plus c. So how would we prove that? The derivative of negative cosine, so I'm going to prove this formula by undoing it. The derivative of negative cosine would be negative, the negative, just that negative came along for the ride, times derivative of cosine, which is negative sine. The negatives cancel, and you just get sine. The derivative of c is just 0, because c is a constant. So going forwards, derivative sine is cosine. That's the one you memorize. Everything else revolves around this one. Remember this one, and then you'll be able to figure out all the other ones. Derivative of sine is cosine. So antiderivative of cosine is regular old positive sine. It's really easy to get those signs mixed up. The antiderivative of 1 over x dx, this is a brand new one. We haven't talked about this one yet. Is the natural log of the absolute value of x plus c. Now, we're taking a version of this course. This is Calc 1, Early Transcendentals. That's the name of the course you're in right now. There's another version it's just Calc 1. It doesn't say Early Transcendentals, where you actually prove this. And we prove this. It's a very complicated proof. It's really fun. Like, I enjoy teaching Calc 2 that way. But then you don't get x, e to the x, you don't get natural log of x, you don't get any of those in Calc 1. Like, you don't even see natural log until Calc 2. This version of the course gives you these formulas without proofs. I'm not going to prove this. I will say, remember, the antiderivative of x to the n dx, where n is a real number, is x to the n plus 1 over n plus 1 plus c. That's our power rule, right? Like, we know, for example, the antiderivative of x squared dx would be raise the power up by 1 and divide by the new exponent. That formula doesn't work here. If I tried that, that's x to the negative 1 power. If I tried raising that up by 1, negative 1 plus 1 would be 0. So I would get x to the 0 over 0. What does that mean? You can't divide by 0. That's undefined. This power rule formula only works if n is not equal to 0. Oops, I lied to you. If n does not equal -1. That power rule works for every case except this one. For this one, the antiderivative of 1 over x dx is natural log of the absolute value of x plus c. And again, we're just going to take that without proof. You got to remember that absolute value, though. And you got to remember you cannot use power rule on this guy for his antiderivative. Okay, and then we had all those formulas for the derivative of arc sine and derivative of arc secant and all those. Like the antiderivative rules just apply going backwards. I don't expect you to have any of those memorized. The one that does come up the most often, though, the one I do want you to recognize when you see it, is this one. The antiderivative of 1 over 1 plus x squared is the arctangent or inverse tangent of x plus c. This comes up all the time. It's one of the most important antiderivatives. We can prove this formula using trig sub. You'll do that in calculus 2. For now, we're just going to take this as given. We actually already derived it way back when by showing that the derivative of inverse tangent is 1 over 1 plus x squared. Now, this is in our formula sheet. Remember, you get a formula sheet. So you don't have to have this memorized, but it's going to come up so much, you might just want to go ahead and memorize it. Okay, that's a good place to stop there.